The purpose of this video is to review the formulas for circumference and arc length. In the previous assignment, we used the circumference formulas to find the circumference and the arc length formulas to find the arc length. But today we're going to use the circumference formulas to find the diameter or radius of the circle, and we're going to use the arc length formulas to find the arc measure or circumference or diameter or radius of the circle. Remember, there's really only two formulas, not five. If you look at the first two formulas, they're the same formula, because in number 2, 2 times the radius is obviously the same as the diameter in number 1. The reason that I write two formulas on the screen is so that you remember to use the correct formula when you're given the diameter and the correct formula when you're given the radius. For arc length, there's also only one formula, but I have three listed here, number 3, 4, and 5, and all of them are the same. In number 3, you're multiplying by the circumference. In number 4, you're also multiplying by the circumference, but we're using the version of the circumference that is pi times diameter. And in number 5, you're also multiplying by the circumference, but you're using the form of the circumference formula in number 2, which is 2 times pi times radius. The first example that we're going to do is we're going to find the radius of a circle with a circumference 80 pi inches. So to start with, I need to find the right formula to use, and since they want me to find the radius and they gave me the circumference, I'm going to use formula number 2. So circumference equals 2 times pi times radius. My circumference is 80 pi, so I substitute 80 pi inches in for circumference, and then I have 2, I have pi, and my variable in this problem is the radius. So now I need to solve this equation for r. So to begin solving for r, I'm going to divide both sides of the equation by pi, and on both sides the pi's will divide out, and I'll be left with 80 equals 2r. And now I need to divide both sides of the equation by 2. And when I divide by 2, on the right-hand side, the 2's divide out, and I just have r. And on the left-hand side, I have 40. So what I've just found out in this problem is that the radius is 40 inches. So if I have a circle and the circumference is measured exactly at 80 pi inches, then that circle will have a radius of 40 inches. And that's the answer to this problem. In this example, they're asking us to find the measure of arc PQ. Now remember, if you're finding the measure of an arc, you're finding the answer in degrees. You want to know, on a protractor, out of 360 degrees in the circle, how many of those degrees are the arc from P to Q? That's what they're asking here. So on this problem, I know the radius and I know the arc length is 16.32 meters. So I'm going to use equation or formula number 5 to solve this problem. Now I'm going to substitute the information from the formula or from the problem into my formula. So for my arc length, it's 16.32 meters. My arc measure is the variable in this problem, so I don't have a number to put there yet. There's a 360 on the bottom because every circle is 360 degrees. I have my 2, I have my pi, and my radius on this problem is 6 meters. So now that I've substituted the values from the problem into my formula, I need to get rid of the 360 degrees that's on the bottom of that fraction. So I'm going to multiply both sides of the equation by 360 degrees. And when I do the distributive property here, the 360 degrees on the right in blue is going to divide out the 360 degrees in red when I multiply. and so the right-hand side of the equation will no longer have a fraction. So when I multiply 360 times 16.32, my answer is 5,875.2. When I multiply 360 in red times the right-hand side of the equation, the 360 in blue will divide it out, and I will be left with just the right-hand side of the equation, but without the 360 on the bottom. Now, in order to solve this problem, I need to divide both sides of the equation by everything except for the measure of arc PQ. So I'm going to divide the right-hand side of the equation by 2 and pi and 6, and I'm going to divide the left-hand side of the equation by 2 and pi and 6. On the right-hand side of the equation, the only thing that will be left is the measure of arc PQ, and on the left-hand side of the equation, I will have the answer, which is 155.84 degrees. So if I have an arc length of 16.32 meters and the circle has a radius of 6, that arc measure, or that central angle, will have a measure of 155.84 degrees. In this final example, we need to find the circumference, but the information that they gave us was an arc length of 12.96 centimeters and an arc measure of 51 degrees. So I'm going to use equation or formula number 3. The arc length equals the arc measure over 360 times the circumference. I can't use equation number 1 or 2 because I don't know the radius of the circle, or I don't know the diameter of the circle. So I'm going to have to use formula number 3. Now I'm going to substitute the values from the problem into my formula. So my arc length is 12.96. My arc measure is 51 degrees. And my variable, what I'm looking for in this problem, is the circumference. So my first step is to eliminate that 360 degrees on the bottom of the fraction. So I'm going to multiply both sides of the equation by 360 degrees. And the red 360 degrees, when I multiply it on the right side, and the blue 360 degrees that's on the right side will divide each other out, and I'll just be left with 51c. On the left, when I multiply 360 times 12.96, I get 4,665.6. And on the right, like I said, I have 51c. Now, if I divide both sides by 51, I will know the circumference. And so the circumference of this circle with an arc length of 12.96 centimeters and an arc measure of 51 degrees is 91.48 centimeters.